Hello, good afternoon everyone. I am Priya Tiwari, having roll number 20 NS0319 of 5th semester of Department of Physics, and I am pursuing the graduation from Sikkim Government College, Namchi. Firstly, I would like to express my special thanks of gratitude to my teacher C.P. Khatiwara sir for giving us this opportunity to expose ourselves. Secondly, I would also like to give thanks to our physics department teachers for guiding us to make the assignment successful. So I have got the topic of molecular beam epitexy. So I have the content epitexy. What is molecular beam epitexy? Parts of molecular beam epitexy and its application. Epitexy. So first of all, what is the definition of epitexy? Epitexy is the word having Greek composition of two words, that is epi and taxi. Epi means upon and taxi means orderly arranged. That is, epitexy means one layer is orderly arranged upon another layer. And another definition of epitexy is the growth of very thin crystalline film on the top of the crystalline substrate. So here is the diagram of recombination sites, substrate and the interface of the substrate. This is the formation of epitexy and epitaxial layer and the surface of epitexy. So what is MBE? MBE stands for molecular beam epitexy. So just like here name suggested, we can understand or deduce the fact that molecular beam are used. Here with the help of molecular beams we are achieving the process of epitexy. So the molecular beam epitexy is nothing but it is the system where molecules of different elements are ejected on a rotating heated substrate to form two or three dimensional object. So the entire process is performed under the ultra high vacuum chamber. So MB is non-chemical vapor deposition process and it uses the evaporation methods, and it was not been used earlier, but it has only recently been seriously considered a suitable technology for devices fabrication. Reason behind that the MBE was not used where quality was not equivalent with device needs, no industrial equipment existed. And here is the advantage of MBE and disadvantage of MBE. So in MBE no chemical reaction, that means without any chemical reaction we can make molecular beam epitexy, and it is low temperature process, that is between 400 to 800 degrees Celsius only temperature needed for the process, and it precise dopant control. Dopant control means doping of the impurities, so it gives more control and resistivity, and uh, growth control can be growth rate can be controlled in molecular beam epitexy as, and no boundary layer problems, and auto doping is minimized as doping is directly perpendicular to temperature. So here temperature uses is ultra high vacuum temperature, so autodoping can be minimized by the molecular beam epitexy, and the growth rate can be small as 0.01 micrometer per minute to 0.3 micrometer per minute. That means we can control the thickness of the layer of material. And the disadvantage of the MB is only it is very costly. And MB involves the direct physical transport of material to be grown to be heated substrate. The growth is achieved by directing atomic or molecular beam impurities can get away inside the substrate. Here the parts of MBE. We have the magnetic manipulator, another one is read gun, which is reflection high energy electron diffraction, which is used to shoot the electron on substrate. Or another one is read screen, which measures the thickness of the epitexy layer. Another one is turbo pumps, which generates the high vacuum. Another one is sorter, which control the beams. And another one is the effusion evaporator cell that effuses the solid forms of element into vapor. So here is the diagram of the apparatus. Here we get molecular beams with the help of certain cells referred to as effusion cells by converting certain materials with vapor forms, and it is also referred to as evaporating cells. We have 3 effusion cells here, and this apparatus must be created into a very high vacuum state. For that we have turbo pump over here, and this particular turbo pump start rotating here, and high vacuum is created inside this particular apparatus. Now here we have magnetic manipulator which change the direction of substrate, and we have read gun from which the electron is shooted towards the substrate, and here we have read screen which helps to measure the thickness of the electrons. So the process is when the here from the particular effusion cell the molecular beams are ejected or effused out of this effusion cell and then projected on the substrate to make thin film on the top of that particular substrate. It either fall directly or after striking it bounce here and there. And another one from read gun, also it shoots the electron towards the surface and bypassing towards the surface of substrate, and by passing substrate it goes towards the read screen, which helps to measure the thickness of these electrons beams. And So from Ritgron and the effusion cells, we have collected a film on the surface of this substrate. This is known as molecular beam epitexy. So this is the process in the molecular beam epitexy. So this is the main process inside this. So now application of MBE, molecular beam epitexy, which is used as a superlattices or single crystal thin films also, and it is also used in VLSI, very large scale integration, and ULSI, ultra large scale integration system. So it is also used in modern semiconductor also in IC integrated circuit also. So thank you.